this is the sheet you're going to need. It goes with the next PowerPoint. And what you're going to do is you're going to fill in orbital diagrams. And the orbital diagrams will give you electron configurations. So in the PowerPoint, you may want to squeeze the electron configurations into the right of each orbital diagram. And down the left, we'll talk about number of electrons in each case. Let's see what we got here. So our first one is hydrogen. So you put one electron in the blank to the left. And what we have is a 1s orbital. It's the first one we finish. And we put a slash in like so. That's hydrogen's electron orbital diagram. And then you can write the 1s1 to the right of this on the sheet. It's saying there's one electron in the 1s orbital. We go to helium. Helium has 2 electrons. So you put a 2 in the blank to the left, you'll put a 1s2 to the right, you put a slash, and then you pair it off. The 1s orbital is now filled. So that's the orbital diagram. You put a 1s over the circle, 2 slashes. That's the electron configuration. Got to know the difference between those two terms. Lithium is 3 electrons. So the 1s is already filled from before, and now we start filling the 2s orbital. And that's why it's 1s2, 2s1. Beryllium. Well, we have 4 electrons to find a home for. So we put in 2 electrons in the first, slash, 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 slash. And the reason for these kind of slashes is it's trying to show the opposite spin. We might argue this is a plus 1/2, this is a minus 1/2 for those spins as we go along. Boron has 5. So the 1s and 2s are already filled, and it starts filling the 2p. So its configuration is 1s2, 2s2, 2p1. It's telling you how many electrons in each orbital. Now, when you do an orbital diagram, you've got to be very careful. We're not allowed to pair this one off. It's a lower energy setup if we go into an unfilled 2p orbital. So here we're looking at carbon. So now, this is unpaired and this is unpaired, but our configuration is 1s2, 2s2, 2p2. You can kind of guess the next one's going to be 2p3, and then it'll be 2p4. We're going to start pairing those off before we get to 3s's. So there we are. 1s2, 2s2, 2p3, 3 unpaired, and now this will end up being paired off when we get to the next element, oxygen, because we're not going to 3s, we're going to fill the 2p and go boom, 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 and then we'll be at the end of the second period. So there's oxygen, 1s2, 2s2, 2p4. So that seems fairly painless. Fluorine has 9. 2, 2, and another 2, another 2, another 1. So that adds up to 9. 1s2, 2s2, 2p5. So these are filled, and this part of the subshell is unfilled. We get to neon, a Boston Bruin noble gas, and now notice the 1s, 2s is filled, and the 2p is all filled. That's a very stable arrangement. 1s2, 2s2, 2p6. And that's probably a good place to stop this PowerPoint, and we'll start with the next period and do those 8 elements and get their orbital diagrams and configurations. Orbital diagrams, you got to label the orbitals, spread them out. So here we have 3, boom. If we ever hit a D, we'd have to have 5 circles and start filling them. But the configurations are still very straightforward.